This is issue number 36 for the Kaiju Engine, where we're going to be setting up the shader loader for OpenGL, and we'll verify our shader loader by rendering a triangle. So to start, I actually need a rendering folder because we haven't gotten to any rendering yet. So we'll create a rendering folder. We're going to create a shader.go, and here we're also going to create a shader cache.go. So when we create a shader, it's going to be through the shader cache. We can create a shader independently if we want to, but it will go through the shader cache so that we can share resources without having to new up a bunch of the same shaders. We'll also be going through the shader cache to do our rendering. So that's another thing to keep in mind. Essentially, there's three main loops that you do for rendering. You go through your shaders, and from your shaders you go through your materials, which is kind of like instance data, or is data that's shared across everything that has that material. And then you go through your meshes that are a part of that material and render them. And you'll want to do that through instancing. So the whole rendering process is not what we're going to be doing in this issue. This issue is just about the shader cache and getting a simple triangle loading up with our shader cache. So being that this is also going to be the first time we are going to load a file, in this case, since we're in OpenGL, we'll be loading up the fragment shader, the vertex shader, and we'd also load up any tessellation geometry shaders as well here. We need a way to abstractly load up a file, an asset, because we don't know if it's going to be a file system asset or whatever. It may just be some arbitrary string hash which points to a file. So we'll also go into probably not file system. I think it should be a part of the engine possibly. Now we'll create a new package. We'll call it assets. And inside of assets is where we will have our asset.go. And for now, we are going to write it so that it just loads up the file from the file system, just to keep it simple. Type asset database struct. This really doesn't do anything for now. All we're going to do is we're going to pass in the asset database, and we're going to say read text file, something like that, or read asset. Read asset, and the asset, we'll say key. In this case, it's just going to be a file path. And we're simply just going to do a file system dot read text file for now. And we'll have a different issue on cleaning up the asset system. But for now, we're simply just going to return the text file just so we don't have to modify the shader code later when we're doing asset stuff. So inside of the engine, for the host is going to have an asset database. Asset database. Did I call it asset database? Yeah, I did. Okay. So assets. In fact, this could just be assets.database, honestly. Just less text to type. I don't want to change this to database. Cool. And it's probably not going to be this prefixed. We're just gonna pass the key for now. Just straight load whatever it says we want to load. So we'll pop in this guy, asset database, and we need to new it up. New database, return database. That way, inside of the host, we can say asset database assets new database. Okay, cool. So now we're going to create our package rendering. And I guess before we make the shader cache, we have to make the shader package rendering. We need to then create our struct. shader struct. Now the way that we create the shader is going to be different between Vulkan and OpenGL. OpenGL reads the text files, compiles at a runtime, and then that's how it goes. Vulkan will have SPIR-V files. We'll have to create a pipeline, a shader pipeline, and all the other stuff. So this is just the raw, the raw identity of what a shader is or can be. So first of all, we can have shaders with subshaders. So I'm going to create a subshader shader, and we may make that an array later, but for now it's just going to be a pointer to another shader. We're going to have the key name, which is just going to be the key for this shader, and we're going to compose that in some way later. For now, it's just going to be the name of all the file paths that make it up. So vert path, frag path, geometry path, and then we have the tessellation. So TESSCTRL. I guess I could just call it control path. That way it's the same length. And let's see. And the next one's going to be eval path. So those two are going to be for tessellation shaders. And then we're going to have a couple of other bits of data related to the shader, the identity of this shader, depending on whether we're in Vulkan or if we're in OpenGL. Those identities are going to be different. In OpenGL, it's just a GL uint, I believe. So rather than have that directly here inside of the shader, we're going to abstract that out to another location. But for now, we'll stop where we are here and worry about that when we get to it. So we're going to create a new shader. Very simply, we're going to pass in, we're not going to pass in the key. The key is going to be generated based off of our various shader parts. And I can just create that key function now, func create shader key. We'll pass in these guys, and we'll do something very simple, like just making it so that it is a concatenation of all of them. But we can have them glued together with like a terminator or something. So we can say strings.join. Whoa, what happened there? Whew. Strings join, and we're going to join together this array of strings with a terminating character. So that will be our shader, and we'll set up these guys just like that, and that's fine for now. We're probably going to do some more stuff in a bit. We're also going to be setting up order independent transparency later, so that's something to keep in mind. We're going to have a shader that has this block of code in it defined out for order independent transparency. We're probably going to look for that inside of the shader itself, either the file name or within the text itself, something like that. Now we are also going to want this to be a pointer just because there are some caveats. Obviously, we're interoping with the C runtime or just like a C-level API. So there's special destroy functions for these shaders when we create them. So I'm just going to put something together here just to stub in that, and we may change it a little bit later. But for now, we'll just do a runtime dot set finalizer for this shader, and we don't need the finalize. We're just going to put a function here. Func s. All right, we already have s there, so shader. And then to call the renderer free function for shader. So obviously this doesn't actually create the shader, it just sets up the shader itself, and it hasn't been created on the GPU in any way yet. So we're going to create a function as shader, called delayed create, and we'll see why it's delayed in just a second. But first, we're going to pass in our renderer, which is going to be OpenGL or Vulkan, or it could be DirectX in the future or anything like that. And then we're going to pass in our asset database here, asset database, and it'll be a pointer to the assets.database. So the reason this is delayed is because at runtime we could spawn objects, and this could be on a separate thread or anything like that. And we don't want to go in and do stuff in OpenGL or inside of Vulkan on the separate thread at that moment. We're instead going to say delay the creation of the shader until we're ready to go through the renderer creation pass, which would happen before our render happens. So that's why we named it delayed create. So here we don't have a renderer. This is going to be an interface, but we're going to have a function on that renderer. Like I said, this is either OpenGL, Vulkan, or whatever. We're going to have a create shader function that is a part of that, and we will pass in this shader and the asset database into that so that it can do any kind of construction that it needs to do. And if this shader has a sub shader, then we're going to want to do the delayed create on that sub shader after we've constructed this shader. So that's all we're going to have here for now. And now inside of we can build out what's going to be in the shader cache. So in the shader cache, we're going to have a type shader cache struct, and then we're going to have access to the renderer. We'll just keep a reference to it until we realize we don't need it. We'll also keep a reference to the we can keep it a reference to the asset database in here actually. Asset database assets.database, which means we don't really need to pass in either of these, do we? Oh yeah, we do, because this is just going straight to the renderer and calling create given itself. So those will probably come from here actually. So now we have a list of shaders, which is going to be, they're going to have their key set up there. And then we're going to do pending shaders. This will be an array of shaders. These are the shaders that are currently waiting to be created because they've been requested. So now we need to create a new shader base, or shader cache. I read asset database. We do want the renderer, we want the asset database, and we don't need to return a pointer in this case. It could just be housed in whatever object that we're putting it in, which is going to be the host. And so we're going to set up the renderer, set up the asset database, we're going to make the shaders, then we're going to make the pending shaders. So next we're going to have a function for creating the shader. So func shader cache, create shader, vert, frag, geometry, control eval. So that's pretty good. We are also going to want to put in the drawing type, because we can draw with lines or triangle fans, whatever the API gives us. But for now, we'll just leave it like this and add that in when we need it. So let's see here. We actually want to get the shader key first, given the asset keys. And if it does exist, we are going to return the shader. Otherwise, we're going to set up this new shader and add it to our pending keys. So let's just do var shader return. Oh, I guess I could just put this in here. And then we're going to add it to our pending because we'll be creating that when requested. So for that, we'll do func shader cache and it's not going to be update. It's going to be create pending, which will go through each of the pending shaders, and we could call renderer create directly on it, but instead, just so that shader is a little bit more in control of its own creation, we can do s dot pending, or not s, do shader, what? Oh, pending shaders. Pending shaders is an array. Okay, yeah. Shader dot delayed create renderer database, and then I think in Go, in the new version of Go 121, we can just do clear and pass in pending. We don't need to reassign it. Unless that's just for maps. Hold on. The clear is built-in function that clears maps and slices. Nope, it clears slices. Cool. Okay, so now what we're going to deal with is that pesky renderer that we haven't set up yet here. So we'll need to create an interface, renderer.go. I don't know what all we're going to put into this yet, so we're just going to make it very bare bones with the functions that we need. So type renderer interface, and let's see, picked up create shader, free shader, yep, we'll need that. We'll leave it with just that. It's going to have obviously a lot more, but I think that gives us what we need. So now here, well, here we have a problem where we don't have the renderer, and so we need to pass that in as part of creating a shader so that we can free the resource when it is no longer being used. So we'll pass that in, renderer, and we can then do renderer dot free shader there. We'll just leave it as a finalizer for now. We can come up with a better way of doing it later. But shaders generally are not going to be constantly freed. They're going to be queued up, used for a long period of time, probably forever even in many cases. So especially with Uber shaders. So doing a runtime set finalizer doesn't bother me too much in this case. So let's make sure that we pass in the renderer here. And then lastly, we need to actually set up these functions for creating and freeing the shader for OpenGL. So what we can do here is we can say renderer.gl.go, rendering, and then we are going to have some build constraints here for if it's OpenGL possibly, unless we still plan on doing that at runtime. But we'll leave them off for now. So we'll call this type GL renderer struct, and Vulkan renderer is going to be VK renderer. I'm just going to stub that in, renderer.vk.go package rendering struct or type VK renderer struct. There we go. And then we have our two functions we need to implement here. So we'll just paste those here. And we'll go into the VK, renderer VK, paste those in there. Func R pointer VK renderer. And we'll just panic on these. Panic implement me. No, I say nah, not implemented. Cool. Let me just copy this. Actually, just paste it over here. And we are going to implement these. So to create a shader in OpenGL, we're going to have a couple of functions. One is going to be creating the shader objects, and then the other is going to be linking the shader together. So I'm going to create a func create shader object, and then we're going to pass in the asset database. Asset database, we do not need all of these because this is a generic function file. We'll call this shader key string, And then we're going to need to put in the GL handle here. So in this case, the handle is going to be a Win32. So we'll call this handle. Sorry, not the handle, this shader type. We'll call this shader type. The handles we're returning from here. So we're going to start off by reading from the asset database the source for this shader. Read asset, and this can return an error as well. If error is not equal to nil, we'll panic for now, just to keep it simple. Okay, so at this point, actually, we need to go and create this stuff because we are going to want to create, for example, the wrapper functions into OpenGL. And of course, there are some built-in functions available to us already, some other libraries, but we don't need all of that. We just want to get the ones we really care about. So since I don't really want to pull in that whole thing, that big old wrapper for GL, and I already have GLAD set up, I would like to make it so that I can just simply wrap the functions myself. The only two libraries that I currently have planned that we're going to be using are going to be the Vulkan wrapper and the Go interpreter. So what I'm actually going to do here is I'm going to create a new folder called GL, and we're going to take that code we had inside of window, all this GLAD stuff, and we're going to move it into GL. Okay, now all that is in there. We now need to make it so that when we reference GLAD here on Windows, we got to use the relative path go or GL slash GLAD wiggle, and I think that was the only place we included it, and the rest just include themselves locally. Okay, I'm going to close all this, clean up my workspace. Actually, I'm going to comment that out because it's going to keep trying to import that library every time I save. And let's close these. Okay, so now we have a GL folder. Inside of our GL folder, I'm going to create a we're going to focus mainly on GLES cross support, so it works on a browser, works on a phone, and it works on desktop. We're going to be we primarily want to focus on Vulkan for all other platforms, including desktop, but just have it as backup. So I'm just going to call it GLES dot non.js.go. And these are the functions that are not going to be included for this is for the non.js build. So go build not JS and not WASM. We'll just do that. And the package is just going to be GL. And essentially what we're going to be doing here is we're going to be including that C code for GLAD and then wrapping the functions we need. So we'll start by creating a generic GL handle. Handle is equivalent to a Uint32. That way over here, rather than using Uint32, I can say gl.handle in both of these cases. And of course, I can separate these out to be specific for shader stuff if I want to. So to test things out, the first thing I need is a create shader function. So create shader, which will return a handle. And it will take in a shader type handle. So let's do import C here. Import C. And we're going to include glad.h, which is locally here. So instead of glad.h, let's look for create shader. GladGL create shader. GladGL create shader, GladGL create shader. Should probably do a regular expression to search for the one I'm interested in the most. So I don't see the one I want. I see all these separate ones. Okay, after doing some explicit searching, I found the define I was looking for here. So we want to, this define is runtime or build time because it's a macro. So it looks like it just calls glad create shader, which might be the one we care about. We'll see if it exists. If it doesn't, we're probably going to just, I mean, the easiest thing to do, honestly, would just be to create a function inside of C to explicitly just call that macro, which might be good just in case the glad library changes or anything like that. So we'll make it do that. So let's see what the return value of this is. This passes back a GLU int, so we're just going to copy this. So it returns a GLU int. We're going to call it CGL create shader. And it takes in these 4 arguments. Create shader program. So we'll just paste those in there and then return type count and then strings. Okay. Now what's this complaining about? Include expects file name. File name glad.h, glad.h. Okay, we're just going to leave it like that. Now we want to call this guy. So C or return C dot this, or I can assign it because it's going to be of type GLU int. C dot GLU int result is equal to, and we're going to pass in our type, and we'll come back to the rest of this in just a moment, and then we can return handle res there. But I'm pretty sure GL create shader only takes in a type. Then you bind the source, and then you bind the you compile the shader. So let me double check this real quick. Sharp define this. Create shader goes here. Proc. Oh, it's right above it. I don't know. I must have went to the wrong thing. So yeah, it just takes in a GLM type. Let's get rid of all that. My bad. Takes in that type. Just make sure everything's the same. Returns GLU int. Then we're just going to call it with the type. That'll give us our result. Expected terminator. Maybe because it doesn't understand that. So we're gonna try out this create shader function just to see what happens here, and make sure that the other stuff compiles just fine. So we're gonna go into main, and at the top we're just gonna call gl.create shader gl handle 0. That's fine, and gl needs to be included. We'll compile this and see what we've done wrong so far. Oh, it does expect the terminator. Where does it expect the terminator? I must be blind. Oh, wait, first of all, we don't need all these arguments. Is that what it's complaining about? No. Oh, I'm defining it like it's C, like it's C. My bad. There we go. All right. Let's also put a breakpoint on these guys. Okay, now it's getting happy. So now we can go in and we can see what we get out of it. So go in here, gonna step in, step over, and we got a error. Oh, this is because the nothing has actually been created. We haven't created the window which sets up the bindings for GLAD. So let's move this down to here and then run that. So now let's step into it. Our window just got created in a background thread. Hopefully that was fast enough. It was not. Okay, well, I can just take this and put it after our first update. That should be, it should wait until there are no more events before hitting that. Surely. If we still break, it's probably some other problem then. Okay, so step into, step over. Nope, still break. Let's actually read the error, I guess. Oh, this is likely because we're on a different thread than the OpenGL, and it doesn't have context. So let's go over to, let's do our test inside of windowing. Window. Now our Go thread, we essentially say window Go essentially says, let's see, poll process events is crashed, create window. So we say Go, and that's what's running that thread. It's back there on the other, in that other space where the window is, and that's where the context is being bound to. We could bind that context to a new thread and deal with all of that sort of trouble there. However, I'm going to try to do a little hack here and see if it will make it happy. We're going to do func. I don't know. We'll just keep it simple. Go thread. Window thread. Doesn't matter. We're not keeping this. And rather than say go and then see all this stuff, we'll put C and all this stuff in here. Oh, but this is blocking. It spins on the. Now we've got some trouble here. Okay, so generally, whenever you coding linearly like this, you hit these kind of impasses. So there's a couple of paths we can take. We could offload all of the creation stuff to Go, and then we can communicate that by saying, hey, I want to do something inside of the, did I say Go? And we can offload all the creation stuff to C, and Go can just say, hey, I'd like something, and then have it go created in C, and then come back with the handle. So Go knows it has the handle to what it requested to be made. So that way allows us to have all of our rendering code inside of C and managed inside of there. And then we just deal with all of our business code over here inside of Go. The other is to expose the methods, and then I would have to create an interrupt between C and Go for whenever we want to create these assets. We say, hey, I want to create this stuff. And then it would have to either get context or it would have to queue it up to be run on the same thread as the window where the context already is. And I don't want to do context swaps. So I'm kind of leaning towards doing all of the construction code inside of Go or inside of C and then just handing off the handle back. So the one problem with that bit is that the handle itself may be created a later time, because on Go it's on one thread and it says go do this thing. And then when C gets around to it in the context, it runs the create and it generates the handle. And that handle needs to come back to Go. So we'd have to either give a pointer to C to write into, just like we do with shared memory, or we'd have to find a way for it to call back. And we don't want to call back into Go. Calling from C to Go is expensive. So it may be a little bit of a hack, but we may get some good performance out of offloading everything into C and not having that crossover. And we're just queuing up things from Go, like create a shader, here are the strings. Perhaps it may be faster. I have to think about this for a minute. I suppose the alternative, simpler option would be to run the window and its polling on the same thread as Go is doing. So rather than say Go, run off there and spin lock inside of the Win32 header code. So rather than doing our spin lock here, we can go through all the messages while there are messages to be read, and when there aren't any, it falls through, and we can come back to doing this, and that's also probably a little bit easier to work with as well. Another reasonable alternative would be to pull the context into the Go main thread and pull out the GL clears and swaps. With the only problem of not knowing when a paint has happened, so we'd need to either communicate that over the event stream. I mean, it should be it will be communicated over the event stream because of us writing the information to shared memory here. The event type is going to be uMessage, which is going to be the paint. I just don't know if Windows is going to complain about painting on that other thread. So I think I can call it. I can call it here for now. We'll come back to completing the shader code. Of course, in this video, you're just going to see it fully, just straight through. I'm just going to come back and continue this. But I'm going to call it here for now. Going to navigate these context waters and do some thinking about how I'm going to go about it. And that'll probably be in a separate issue in a separate video where I solve that. And then we can come back or I'll come back and finish up this. Okay, this is a continuation of issue 36. I have finished issue 37, which is what I would have been just talking about in this video to get GL calls running on the main thread. So I'm going to make sure that code has come across, and I'm going to try calling this GL create shader. And this is in the update loop, but I just want to make sure that it's still working. Cool. So we can finally continue on with where we were, and I'm going to have to remember where that is. Just a second. Oh, right. Okay. So we are going to create a shader here using GL create shader. We'll do some stuff with order independent transparency here as well, but for now, we're just going to do a gl.shader source. I'm going to pass in the shader and the source, and the gl.compile shader. Then we can do res equals gl dot get shader parameter shader gl dot compile status. Okay. So at this point, we've got 3 new functions we need to implement. So let's go over here. We're going to need func create shader or shader source. Let's take the shader handle, source string. Yep. Then we need compile shader. compile shader, and then we need get shader parameter. Okay, so we're probably going to change up some of this. This is just the auto-generated stuff. And then compile status is going to be a var here, var compile status. And this compile status is likely going to be a part of glad. So I'm just going to copy this value. Compile status equals that. Okay. Now we need to create a, I'm just going to call these CGL. So we're not stomping on anything we don't intend to stomp on. CGL create shader source. So create shader source. Yep. We're just going to kind of go down the line here. We shouldn't need the length. Let's check out GL shader source inside of glad. So let's go to this count shader. Oh, I guess it does have all that stuff. Okay, that's fine. Length, GL shader source. This doesn't return anything. Yeah, it's void. Okay, and then we need the CGL shader. We have create shader, shader source. We need a compile shader. So void compile shader. I'm going to pass that along. And then we're going to check out compile shader. And it just has that, no return. Okay. And then we have GL get shader IV. Let's take a look at GL get shader parameter. Is that a function? No. Okay, so GL get shader IV takes in the shader parameter name, number of parameters there, or the address of the parameter result. CL unit return int32. So, and here it's going to be a GL int. So I think int32 is fine. So that should give us everything we needed. Compile status. We're going to change this to const compile status. So that it's a little cleaner here. Okay, so now we want to say if the res, this is going to return 0 if it's okay. We'll just do a type. I don't know if we should just call it result. I guess. Result is equal to an int32, and we're not going to do an equals because we're going to have a func our result is okay. Return r is equal to. Are we sure about that? I think I want to look for. Yeah, I'm pretty sure it is. If it's not equal to 0, it's okay. 0 being false, this would be like a GL false. So if res.is okay, and then of course we're going to change this to be a result. Result res. No, we're done if it's okay. So we should return shader here, and I'll call this shader obj for object. If we're not okay, we need to figure out why we're not okay. So we're going to say res is equal to gl.get shader parameter, shader obj, and then shader type, gl shader type. This is another constant. So let's go to glad, look for shader underscore type, grab that number, pop it in there. Of course, we could probably just paste the whole list, but we'll just spot check what we need for now. Okay, so the result is shader type if res.equal, and we'll just make an equal function, but we're going to say gl.fragment shader. Then we're going to do this one, else if equal to vertex, else if it's equal to geometry, else if equal to compute, else if tessellation control, else if we're not going to do compute at the moment, so I'm going to cut that one out. Compute stuff will be its own thing. So we want to get the shader type, so s type of var s type string. We'll say s type is equal to fragment, vertex, geometry, tessellation control, tessellation evaluation. Cool. Else it's going to be unknown for now. Okay, so we need to go create these guys. So let's just grab all these guys to make into constants. And we need to find them over here. Fragment shader. Fragment shader. Vertex shader. Geometry shader. Test control shader. CT control shader. So there's the tessellation control shader. And then evaluation shader. Okay. We have all those constants set up, and now we just need to set up this equal. So func r result equal bool, and this is going to take in a just int32, I guess. I'll just say value. Return int32 values value. Okay, so now that we have all that set up, we can set up our error log. So error log is equal to gl.get shader info log, shader object. If their length of error log is greater than 0, that means we've got a log, else we don't have a log. So if we do have a log, we're going to say log.fatal f. This probably shouldn't be fatal in the future, but error compiling, is this compile? Error, yeah, error creating, why do I have to create shader object? Shader object, we'll say compiling shader SSLN. Okay, otherwise we'll say compiling shader S. Let's see. This is an unknown error. So rather than unknown, we can say there was an error compiling the shader and it could not retrieve the error log for unknown reasons. Cool. So now we need this function. Notice a pattern here. I don't know if that's it, but we'll check out this to see. Is there this function? Glad get shader log. So these are our arguments. I'm just going to go ahead and make this function. This is going to be void. These are the arguments. This is going to be get shader info log. CGL get shader info log. GL shader info log. We'll pass in the buffer. So let's see what it did down here. We don't need that. Oh yeah, we do. We first need to get the length of it. So that pops out. Yeah, okay, this looks right. We first grab the length of the log if it's there, otherwise return blank. And we create a byte array long enough to house that length. I don't know if this includes the terminator, but we'll find out, I guess. We pass in the shader, the length, the char pointer, and then we return a string log. Okay. Cool. So that will give us that information. Just go up here and click this. So the next thing we need to do is we need to link the shader. The func link shader vert frag geom test tse gl.handle gl handle gl.handle is coming out, and then we need to say shader is equal to gl create program new function gl.attach shader. We're always going to have this vertex and fragment shader for now. And then we can say if gl.valid handle. I guess we could just say if geom.is valid. And we're going to attach that one. If the tessellation control is valid, then gl attach shader that. And if the TSE is, we'll do that one. Now we'll do gl.link program. And then we're going to check for linker errors. But before that, let's just go create these functions. Create program. We're going to return a handle. CGL create program. Making sure all those came out as CGL. Void CGL create program. Return. This isn't going to return that. We're just going to return a uint32 t, I believe, or a gluint. I think gluint. We can check. It's going to return, yeah, gluint. So we'll return a handle because the handle is a uint32. Cool. And now another thing I want to do here is we're going to take that out and do type, or we'll do func h handle is valid. Cool. So we've got that placed now. We have create program. We need attach shader. CGL attach shader. It pretty much knows what we're doing here. Going to check those arguments. gluint and gluint with a void return. gluint with a void return. And those are being cast. Okay. So now we need to link the program. Func link program. Let's go up here. CGL link program. That's going to be a gluint for sure. It's a handle. Okay. So now we've done all of those, we need to check for linker errors. So check for linker errors. Res is equal to gl.get program parameter shader. And then we're going to look for link status. If it's not okay, then error log is equal to gl get program info. Then we can do log.fatalf. Error linking a shader. Yeah, that's fine. And then we can return shader. Cool. So now get program parameter and get program info log. So get program parameter and get program info log. It's going to be similar to the other one where we do the get IV stuff. Get info log. And we also need void cgl get program IV. Is that the one that I was going to do? So let's check out these. Program pname parameters void. Program pname parameters void. And then this one. Program buff size length char. Program buff size length char. Okay. All right. Now we have those. We need the link status constant. Link status. GL link status. Next one. Okay. It's equal to that. Okay. So that makes this happy again. So now we've got our object creation and we have our linker. We can now go through and set up our creation. This looks mostly right just from guessing. This just needs to be, we don't need this. We need to define the var geom tsc tese gl.shader. We're going to have a shader type. So geometry tsc tese geom path tesc. Do we not have that? Oh, control. That's right. Control eval. Probably will change this later. So this will be shader vert path. Yeah, it's the shader key. Frag path, geom path, ctrl path, eval path. And we are going to link all of those guys into the final shader. So shader dot. This is where we're going to get that handle I talked about. So we have a GL handle, and we can put that directly in here, but it's not going to work for Vulkan. So we have we can put it inside of here, or we can put it inside of another file, but since this one is well, let's just make a interface for it. Type render ID and then interface. So it's kind of just a type def for now. So we'll have to see what we do with this, but for now I'll just keep it simple and pass in a render ID into that. So now we can say shader.renderID is equal to the result of the link shader. Now we do gl.delete shader vert frag geometry des if tse is valid. Delete that one. So we can go through and delete all of those objects that we created. So let's create this function here, and that's going to go here. Delete the shader, and we need to make this function. What? No. Void delete shader. Okay. Cool. We can create a helper function for getting the GL int out of a handle, I think. Less casting everywhere. I'm just gonna do that real quick. Okay, I created a bunch of these. I created this as GL, which will just do that cast for us, like so. Just moves it up over here. So that gives us our, where are we at? Here we are. It gives us our functions for setting those up. We need this GL shader. Can just be a handle, honestly. I think that's what it was. Handle. Here we go. And I don't like to check against that. I don't know why. Length is greater than 0. I'm probably going to make a helper function for that, or maybe there is one like strings is empty, or I don't know. Includes like white space trimming or something. Okay, with that we can create a shader. So, our last one is a free shader. So let's create a delete program function. Func delete program. This should be CGL bro. CGL. That's probably what was tripping out, guessing it before. Cool. Render ID as a GL handle. Yep. Okay, so now we can try and create a program and see what happens. We'll just do that. I only want to do it once. So once the window is created, we should be able to create a shader. So the first thing actually what I'm going to do is I'm going to go add the shader cache to the host, which if you remember is our mediator. So let's put it up here by window, shader cache, rendering.shader cache. And we'll want to create a shader cache. New shader cache. And this wants to have a renderer, which we should be able to get from the window, and an asset database. So we'll have to actually just do host is equal to this, return host, comma nil, host.shader cache equals new shader cache, where we are going to get the window and pass the asset database. So we'll do host.window.renderer. So whatever renderer the window is currently using, which of course we need to create. So let's go up here. Instead of our window, we need to add, we have a keyboard, we have a mouse, we have the handle. We need the renderer, and rendering.renderer set up here. And out of cheese, to do select the correct renderer or pass it in. Renderer is equal to a new, did I call it new GL renderer? Where is our rendering? Renderer GL. Oh, we don't even have a function for it. Func new GL renderer. This doesn't need to be a pointer. It is maintained by the window. New GL renderer. As long as it satisfies create and free, it should be good. Cannot use NeoGenerator value of rendering GL renderer as rendering renderer because literal does not implement rendering renderer create shader as a pointer receiver. So why is that? And if we need it, then that's why. So free shader, are we doing anything with the renderer here? No. Create shader, we're not doing anything with the renderer here either. We may with Vulkan, so that may change. So for now, this is good enough. So now we have a renderer inside of our main. We're passing that renderer in. Oh, I guess this should be a pointer, honestly. So we're dealing with the interface. Well, no, it's fine. It'll force itself once we have to use pointers, which we likely will. So now that we have a shader cache, we can create a shader. We do host.shadercache.create shader, and yep, we can just create. This is just based on the file system. So I'm going to create a dummy file inside of, let's see, I'll make a content folder, content, and we'll make 2 dummy files in here, vert.frag, vert.frag, basic.frag, basic.vert. And we'll come back to implementing those. So we'll say content slash basic.vert, content basic.frag, and then we can do host shader cache dot create pending. We can do that as part of the host update. We'll pull for events, we'll do our updates, and then do rendering stuff. We'll do that. I guess that kind of denotes that. So it creates any pending stuff and then does the rendering stuff after that. And then I guess we can move this clear screen and swap buffers over to here. Clear screen can probably be somewhere else, but we'll have it here for now. That's fine. Host window, swap buffers. Okay, so we should probably set up a very basic vert and frag where we just do a simple triangle. Okay, I'm just going to grab a little program off the internet because I don't have one on hand that is as simple as I want it to be. And then we need the fragment. Okay, so basic vert, basic frag, just drop this in. This will just set the fragment color on all of them. Do I need these Fs? I don't think I need these Fs. Let's get rid of those. Basic vert, we just take whatever the incoming layout is and pump it straight through. So let's see if we can compile a shader. That'd be neat if it works first try. Of course not. CGL. Let's see. We want this guy. Get shader IV. Apparently we don't have this. Get shader IV. And the other one is c.free because we need to include stdlib. Okay, undefined info length. Info length. GLenum. Info log length. Oh, that's an enum. So is that a constant. Let's go to glad.h info log length. Yeah, it is. Let's paste that up here. Order doesn't matter. Okay, we're running. So let's step into this. I usually use hotkeys, but I think my hotkeys are bound to stopping the video recording, so I'm going to use these silly button clicks. So we're going to create the shader key, and the shader key is missing the terminator. That's fine. It'll generate the same thing every time. I'll come back to why that is. We shouldn't have the shader. We're going to create the shader, and we're going to add it to the pending shaders. So we'll continue till we hit the pending. We have a pending shader. We're going to do delete create shader. Okay, our asset database is set up to do whatever it is it does. So let's step into Vert, and we're going to read the source. Yep, we got our source. Create the shader, compile, check if it's okay. It says it's okay, so let's see what res is. Yeah, it says it's okay. So let's create the frag shader. So we had that should be right. 1 and 2. These are the first two resources we're making. We don't have geometry, tessellation, control, or eval. So did we get a render ID? We did. 3. Excellent. So we're creating the resource for our shader. And we got the IDs we expected to have. Cool. So I'm just going to check on that shader string here. Join concatenates the list of elements of the first argument to create a single string. Separator string. Separator is placed between the elements and the resulting string. Oh. That's why you gotta keep check on that AI when it generates stuff. Okay, so we're successfully creating and compiling this shader, and now we want to render this guy. So I'm gonna just pull out that shader there, and we're probably just gonna shove it right here at the bottom of the update. Why not? And see what happens. So we're going to start off by creating our verts. It's very rudimentary. We're not going to actually have something this simple. We're going to need the texture coordinates and all kinds of other stuff. So it is going to be 0.5, 0.5, and 0.0. Then that one is correct, and that one is correct. So there's our verts. So let's just we're going to create our resources. And this is going to be done inside of some mesh code, but we're not interested in the mesh code right now. We're just interested in getting these shaders up and running. So we'll say V should be VAO. Okay, the way I have this sample set up, it has VAO, it has VBO, the vertex buffer object, and the vertex access object set up separately here. We're just going to set these as GL handles. So var gl.handle. So we need to generate the vertex arrays for VAO, VBO. I'm going to swap these because why not? Then we're going to generate the buffers, yep, for the VBO. And then we're going to bind the vertex array. And then we want to bind the buffers. This is all pretty straightforward, so it's probably going to guess correct on all these. Then we want to do buffer data, vertex array buffer, or array buffer for the verts. And we'll have to pull the length out of this in the other place, and then static draw, that's fine. So next we want to do the attribute pointer to say that we are going to be reading 3 floats from this block of data here. And there are float 32s as our engine is being initially set up. We can change that later. And then we are going to set that to the 0 index of the layout. And then we want to do gl.bind buffer GL array buffer 0, so basically unbind, and then we want to unbind the vertex array. Now these are all functions we don't have. Just gonna bring that in. So we'll need to make all those, and these defines are gonna have to be made constants. So we did move the swap stuff into the update. So I'm gonna comment these out for now, even though they are in their appropriate place. And I'm going to just paste them here for now to test. So we are going to clear the screen, and then we want to use the program, the shader. And it's not going to be program, it's going to be render ID. Of course, this is probably, we're likely going to turn this into a function inside of the shader, which is going to split between the different renderers internally, so we don't write all that in here. But again, keeping it simple. So we're going to bind the vertex array, and then we're going to do triangles 3, and then we are going to swap the buffers. Okay, so let's go make all this stuff. We'll start with the, I'm going to save that. We're going to start with the consts here, and that's going to be inside of, I've got too many things open. I'm going to start closing all these. Okay. So we need a few constants. We need array buffer. We need static draw. We need float. We need triangles. Okay, so GL array buffer. GL static draw. GL float. And GL triangles. Cool. We'll come back for these. Like I said, I'm probably going to come just blatantly copy a lot of these, although I really don't want to have all the stuff I don't need. That way when we look, all what you have is there, and it makes us question when we add stuff if we should be adding it. So we need all these functions. Let's see. These are all unique here, so I'm just going to copy those, just put them down here, and then use program and draw arrays are going to be our other two. Okay, I'm going to make these functions. Okay, I've made all those. You can call me a masochist for not just generating all these with like a generator or something, but I don't know. Could be fun. Also, what's this? This is not right. Let's change this. I think it's C dot jailbool. I don't know. I don't know what that's going to be. Let's just pass it as a bool. Why not? See what it complains about. Okay, let's see if this compiles. Nope, 231. That is likely our little buddy here. We have a GL Boolean. See GL Boolean, try that. Nope, doesn't like that. Cannot convert normalized of type bool to C-type UChar. So cool. I guess let's on char. Okay, well, the internet says there's no conversions from bool, so we're just going to create a uint8 var nml uint8, and that's just going to be 0 by default. So if normalized, we're going to set it to 1. And then we can cast our normal over there. It'll be 0 by default, so I don't need to do an else or anything like that. Okay, that made it happy. So cannot use the main go. Can I just go here? Thanks. The GLU's program, so the render ID we need because we have this set up. I'm just going to do that. Okay, so now we are running, and here, let's see where we die. Invalid memory address. Where did we break? Create shader. We died in the delayed create. Oh, the shader's nil. You have a nil shader in there? Bro. Shouldn't happen. Let's just if shader is equal to nil. Technically, our shader should never be nil, but else use a fallback shader. So this will return nil up here. So why is it nil? We just ran this a second ago. Race condition? No. Okay, well, now I've got something. So unless it is losing its reference as it goes somehow. Okay, second time through the loop. Oh, okay, so it's dying in the second time through the loop. Clear is not doing its job, I guess. Shader cache. Clear pending. What does this do? This is a new function to me, so curious what it does. Clear pending. Oh, I think clear just sets it back to the default. There's an empty map for slices. Clear sets all the elements in the length up to the length of slice to 0. Oh, that's why. So clear does not do what I want it to do, which is I'd have to do a clear and then like a collapse or whatever the function's called. So I'm just gonna do this to reset it. I guess that makes sense. Clear. It's clearing out everything. Awesome. So there's our fancy orange triangle, which is going through. There's a lot more work than I thought it was going to be, but it's going through and creating our beautiful triangle. And I'm not going to do any more work on this to beautify the triangle or anything, or use the correct vertex mapping or vertex data of like UV coordinates and colors and tangents and normals and all that other stuff inside of here. That's for another time. This is just about getting the shader cache working and being able to render a triangle using that shader. So that's it for this one. See you in the next one.